In this video, I will show you how to make Blender run faster, and I will also show you how to render faster in Blender. We are going to make some changes in the preferences of Blender settings. I will also show you some changes in the render settings of Blender to render faster. And finally, I will show you some tricks that you can employ while you use Blender to basically make it run faster. Before we begin, let me show you the specifications of my computer. I'm in fact recording this video on a very low-end computer, although a legendary computer. It is ThinkPad X230. Let's run NeoFetch to see the specifications of my laptop. As you can see, I have this CPU over here and this GPU. Now, to show you what this means, I'm going to open benchmark of Blender here. This is a website that shows a long list of possibly all the devices in the world on which Blender was tested, and we can see which device is the fastest, both for CPUs and GPUs, right? So I'm going to copy my CPU over here and put it right here. And as you can see, my CPU is found here. The CPU that was entered in this benchmark is a little slower than what I have, but this will still do just fine for the purpose of my explanation. As you can see, the median score is 15 for the CPU, which is very, very low. To show you just how low it is, I'm going to delete the search so we can see all the devices here. Let's put CPU over here so we can only see CPUs, right? Here we go. So as you can see, the best CPU that is in this list has a median score of 7099. Okay. Let's go to the end of the list. And we can see the lowest, the median score is like 1.86, 38, and 37. So here in page 37, basically in the very last of this list, you can see my CPU over here with a median score of 15. So in other words, I'm using one of the worst laptops that you can imagine for using Blender. And a lot of people think that you need a very good computer to learn Blender, to use Blender. And I would like to challenge that idea. You don't need the best laptop, you don't need the best computer, you just need a computer and maybe a keyboard and a mouse, right? So I would also show you how good or how bad my GPU is, but in fact this GPU doesn't even exist in the list. And Blender also, as far as I know, cannot really utilize this GPU over here. So it's pretty much useless. This computer, this laptop that I'm using can only utilize the CPU, right? With that, let's begin opening Blender and starting to optimize it. Okay, so here we go. We are using Blender 4.2. This is the LTS version, aka long-term support. For all my videos, I will be using LTS versions because these are the most stable versions. If you want to get the best performance, the most stable experience out of Blender, you should always stick with the LTS versions. Okay, so that's what we are going to do here. Now, this Blender that you see here is already optimized for usage. And as you can see, simply moving around the cube is kind of a smooth experience. This is not like that for the default settings of Blender. I'm going to go ahead and reset it to factory settings. Okay, load factory settings, load. Now, you might already see from the video that simply looking around in the cube is kind of like a jagged experience. It is a little frozen, kind of like skips around, as you can see. So yeah, let's begin optimizing the settings of Blender to get the most out of it, right? We go to Edit, Preferences, and we will do most of the work here in this Preferences window. So let's go ahead and start with the Interface tab and start optimizing the settings here. Now in the default settings of Blender, it's kind of optimized for comfort, but we need performance. We are using a very low-end computer, and you might be using a very low-end computer. So yeah, we don't really need all these, beautifications or things like some stuff that are added for comfort. We don't really need those things to use Blender. So we are going to turn off any setting that we don't really need that might give us some performance boost. Okay. So I'm going to first of all turn off region overlap. Okay. So what happened now is that if you look at the to the left over here, this toolbar that I have that I can turn on and off with the T button. If I hit region overlap, I can see behind it, but I don't really need to. It's anyways obscured by these tools, this area. I don't really need to see this area in my viewport. So just turn that off. Now, our computer has less screen space to draw the viewport. So that's going to give us a performance boost already. Now on the right, there's navigation controls. We don't really need those. We are going to use our keyboard and mouse to navigate around. We don't need that, so turn that off. Text rendering, I'm going to turn off anti-aliasing. This is going to make our text look a little old stylish, I would say. And this is going to give you a tiny little bit of performance boost. So let's turn it off. Now let's jump to viewport. Here we have some important settings. First of all, go to quality, viewport anti-aliasing, and turn anti-aliasing off completely. Then here, turn off smooth overlay, smooth wires, overlay and edit mode settings. You don't need those. For textures, limit size is off. That's good. So for limit size, is default by default is off. This is about setting a cap over what your memory will use for textures. You can kind of leave this off. This means there will be no limit, which is bad for the performance if you think about it. But while we add textures to Blender, we should actually stick to lower resolution textures. And if you do use high resolution textures, you kind of want to see, what they bring to your scene. And you don't really want any memory cap over that. This is going to give you a visual punishment. So let's not do that, okay? Let's leave that off. So here we have also anisotropic filtering. Let's turn that off. We don't really need that. This is going to give us a good performance boost, in fact. Image display method. I believe 2D texture is the most performant one. So let's go ahead and use that, okay? So this is how Blender is going to display textures in the viewport. For selection, I would leave GPU depth picking and GPU subdivision on or off. This is actually not going to make any difference because this laptop doesn't actually have a GPU. It doesn't actually have a GPU that Blender can use. Your laptop might have it. Depending on that, you may want to leave it on or off. I will turn it off because it doesn't really make a difference for my computer. So in the lights, there's nothing we can do. In the edit, there's also not much we can do here. So I'm going to skip animation, just leave that also. In the settings of themes, there's nothing related to performance, so we are going to skip that. Input, there's nothing here. Navigation. For the key map, there's nothing. We don't want to change here except the last setting, which is max shader compilation subprocess. This tells Blender how many CPU cores that Blender is allowed to compile your shaders during render process. This includes both EV and cycles. So what does this mean? Let me bring my computer specs back here. For my CPU, you can see here that I have 4 CPU cores, okay? Technically, we want all the CPU cores to be used for shader compilation. Although, for my case, I'm also recording this video, so my OBS studio is also using some CPU power. If you have, let's say, 4 cores, maybe 2 cores, 4 cores, or 8 CPU cores, you want to crank up that number to how many CPUs you have, right? I have 4 cores, but I would like to give it 3 because I want one CPU to be available, at least one core to be available for other processes, that is, for example, the OBS Studio, such that you can still watch this video without any performance drops, without any frozen parts, right? So I'm gonna enter 3 here. You may want to enter a higher number depending on your CPU cores. Great. That was basically it. For the preferences, we have nothing else that we can do here. There was also this navigation setting here that I wanted to turn off. I don't remember where it was. I think it was in the interface. They change the position of that setting in every Blender version actually, so I keep forgetting where it is. I'm going to find out where it is. It's probably in, yes, over here. So in viewport, 3D viewport axis, let's turn it off as well. See, if I turn this off, these axes are going to disappear. Turn them off, we don't need them. Great. Your preferences will be saved kind of automatically, auto save preferences, except that I hit here load factor settings. After that, if you actually want your settings to be saved, you need to hit save preferences. Otherwise, Blender usually saves your preferences automatically, but just not in this case because we loaded the factor settings first. I'm going to turn it off now, and we are going to do some changes in the render settings. Before we do that, let me show you my viewport now. It's actually much responsive right now. You might have difficulty seeing it from the video, but I feel that the viewport is actually very responsive now. That's a good thing. That's a very good thing. Now let's go to the render settings. It's in the properties window and to this camera over here. You can see the render settings. Both in EV and cycles, we can do some changes to do the renders faster. Let's go over them one by one. So in EV settings, we are not going to change every setting. In my experiments, I did certain changes, but I haven't gotten any performance gains. Those settings I will simply skip. So there's nothing really here. Clamping, there's nothing really here. Ray tracing, stay away from that. For volumes, turn off the resolution 1 to 16th. We are not really going to use volumes, okay? Stay away from volumes. There are tips and tricks to fake the volumes. If you have a bad computer, if you have a low-end computer, and if you want to use certain things that require a lot of performance, such as simulations, smoke, volumes, you need to fake them, okay? So stay away from them in general. Curves, simplify. Simplify is an important setting. It exists both in EV and cycles. You generally want to turn this on and, for example, allow less subdivision. This is going to put a cap over how many subdivision levels you can add to a model, and you usually want that. It basically simplifies the settings, right? So that's what it is for. What this means is that here to my cube, I can add some subdivision surface modifier. If you don't know what is it, it adds surfaces to your models. So now my cube becomes like a sphere, right? I can add more viewport settings. As you can see, after level 2, I cannot really see any more changes because we turned on the simplify. So max subdivision surface was capped at level 2. So I can increase this now, and you will see that it allows more subdivision surfaces now. And now my cube has become almost a perfect sphere. We don't really want that. We don't really want to add too many subdivision levels, because this is going to make your CPU tired, okay? It's going to overload it. You don't really want too many subdivision levels. Let's keep it at 2. And when you add a subdivision modifier or other things that add extra mesh, extra surfaces, vertices to your models, just don't do that. You don't need many subdivision surfaces. Let's turn it off. So you usually want to turn this simplify on, but as you can understand, it's all about how you use Blender. We did a lot of changes in the Blender preferences that is going to give us some performance boost, but the rest of the video is now about how optimized you use Blender, right? How fast Blender will run is also a little bit about you. You need to be able to fake things. You need to be able to keep things simple, right? So let's turn it off. Depth of field isn't really performance related. Film. For film, let's switch to render setting for EV, render mode here, over here. Okay. Now we are compiling the shaders with my three cores. And now this is like um, EV is rendering right now, okay? If I hit transparent here, now you can see that the background is transparent. This is going to give you a little bit of performance boost. So keep that on, okay? So let's go back to the viewport shading. Good. Performance, of course. So we have some stuff to do here. High quality normals, of course not. Memory, you usually want your memory to be used. You want to use your memory, you want to use your RAM as much as possible. So don't play with these settings. Viewport pixel size, this is actually very important. This can give you a huge performance boost. So let's put it to pixel size 8 and let me show you what it does. Do you see those jagged parts now over here? This is what it does. It kind of makes it pixelated, and this is going to give you a huge performance boost. You can see right now that my viewport has become very responsive even when I'm rendering in EV, okay? This is kind of good, and if I wait enough, the pixels are kind of going to go away a little bit. Although this is going to give you, as you can see, a visual punishment, so you may not want to do it. You probably have a better laptop, a better computer than me, than what I have already. But if you have a really bad computer, this is the setting that's going to give you a good performance boost, okay? If I do automatic, it's kind of going to choose pixel size of 1 automatically, which is the highest quality. And as you can see, my computer is kind of like freezing right now again. But if I put it back to 8, you can see that it's actually very, very responsive right now. So this is a setting that you may want to turn on and off depending on the complexity of your scene. And remember that this is a viewport setting. This means that when you do final renders, it is not going to show your renders pixelated. This only affects the viewport. This only affects Blender while you are working with it, while you are working with your scene. So that's a good thing, right? It's not going to take an effect on your final renders. Okay. So let's leave it to 8 actually. You know what? I'm gonna use it at 8. That's good. Let's try 4x as well. This is also kind of good. It kind of feels smooth, but it's not as responsive as the 8x, to be honest. So I'm gonna put it back to 8x, okay? I just noticed, by the way, I'm blocking the view here, so I'm gonna put myself to the left over here. Great. None of these are related to performance, so we are kind of done here. Let's go to cycles render engine, and now we are rendering with cycles. And as you can see, it's very fast. Wow, do I have an NVIDIA RTX GPU? No, not really. The reason why it's rendering very fast is because of the viewport pixel size. So let's go back to performance here. And here you can see viewport pixel size. Let's put it back to automatic. Now the cube looks very crisp, very quality. But as you can see, the render has gotten quite slow as well. You can see the sample size increasing over here. It's kind of slow, right? I can't really see anything. It's very blurry, it's very pixelated with the pixel size 8 in cycles. So you may not want to do this maybe. I'm going to show you a better trick, okay? Let's put it back to automatic. Now, let's go back to viewport settings here, sample count. If you don't know what samples are, it's basically how many samples Blender cycles is going to use before this noisy effect is going to disappear and your render is going to become crisp. Decreasing this number is not performance related. The issue is that my renders become kind of good already around sample 10. So all the other samples that we are going to take, all the 300 samples that we are going to take right now is irrelevant. Okay, I don't need to wait that much. So I'm going to bring my max sample size back to 10. Okay. The noise threshold is a smart mechanism that Blender has where it can understand how much noise is left And depending on that, it's going to automatically skip computing all these samples. So that's a very good thing. And to show you that, I'm just going to wait a little bit. Sample size is increasing and the noise level is going down, of course. And when the noise level goes down to a certain amount, as you can see, look, the rendering is done now. We didn't really render all the, crazy amount of hundreds of samples. We didn't really compute them. So that's a good thing. I recommend you to leave that on. The noise is another great setting that we have since the AI revolution happened. So we can leave that on as well. And here I'm going to make sure that the denoiser runs as fast as possible. So prefilter fast, quality fast, and the start sample is another important metric that you should use. This means that when do we start denoising our renders, right? That's the start sample for that. I usually put the start sample to something around 5. By the way, let's put our max samples back to 10. We don't even need 20, 30 samples. 10 is enough. 10 is enough for our use case. So when I put start sample to 5, you can see now that we are going to render 1, 2, 3 kind of fast. And once it reaches to sample size of 5, it's going to start denoising and it's going to make a big difference in your renders. It's going to really take away the noise. Hence the name, denoise. Okay. Back to the performance settings for cycles and to acceleration structure. These settings over here, they are more related to final renders, not the viewport render that you see here. It's more related to the final renders. You may want to turn them on, but you may want to read what they do. You have to choose them based on your use case. So if you put your mouse over here, it's going to show you the hint. It basically says using spatial splits have a longer build time, faster render. So you may want to, wait a little bit before it renders, but then it's going to render faster. Compact BVH uses less RAM, renders slower. So if you have a very low amount of RAM, very low amount of memory, you may want to turn that on. Persistent data, I don't know why this is not a default setting. It kind of um, helps you speed up the renders if you are rendering an animation or if you are doing re-renders of the same scene. Then it can use a certain amount of data from the previous render and then make consequent renders run faster. So you usually want to turn this on. Pixel size we talked about it enough. Baking, grease pencil, freestyle color management. None of this is related to performance. Great. This is more or less it for running faster renders. Now I'm going to give you some usage tips. Now let's open a scene in Blender, okay? Let's open one of my old projects. Go to open, don't save, army skateboard. So this is an old project that I did. It's my first skateboard that I modeled. So we are going to render this skateboard in the viewport, and I'm going to show you some of the stuff, some of the cool tricks that you can employ to render really, really fast, even if you have a very bad computer, okay? So I'm going to go to render settings here, okay? And I'm going to zoom in, okay? I'm going to zoom in into the skateboard. So much of the skateboard will cover the viewport. Why am I doing this? Because it's going to render slower, okay? It's rendering really, really slow right now. Because there's so much to render right now. So much of the skateboard we have to render right now, okay? In the screen space. Let me put myself back to the let me put myself back to the right. Here we go. So as you can see, this is how fast we render, okay? Now I'm going to zoom out and I want you to observe what's happening. Let's zoom out. Let's zoom out really a lot. Now observe. Do you see how fast it is rendering? Why is this happening? That's happening because right now we have less screen space to render. There is less of the skateboard in the screen to render. Now, what does this mean? How can I utilize this new information to render faster? It turns out all you have to do is open a small window here. For example, on the top right corner of your screen, open a small window here and render here instead. So if you want to do modeling, if you want to do all sorts of modeling, texture painting, sculpting, you can do it on this big screen that you open right here. But if you want to take a quick peek over your final render, all you have to do is open this small screen here, go to render here, and look how fast I'm rendering. And I can zoom in. I can zoom in, kind of look at the details of the skateboard model here, and it's still going to render relatively fast, you know. And if I want to take a closer look at my render, I can, physically zoom into the screen and look at the screen kind of closer, or I can actually use my operating system's zoom feature and actually zoom into the small area just like that. I'm on Linux, XFCE for desktop manager. This allows me to easily zoom into my screen and follow my mouse. If you're on macOS or if you're on Windows, you might have a different method to zoom in like that. Please search about that and you can always do that. So here we go. I'm actually, it feels like I'm kind of rendering now. Um, it feels like I'm rendering on a big screen and I get to look at it in detail. I get to look at it in a very close view. Now you might say there's a trick to this. There's like a catch. What is it? What is it that we are supposed to? What is the catch there? Here's the catch. When I put when I create a small window here and really zoom into it uh, using my operating system, this is the same thing as going down here into the viewport, performance, viewport, pixel size, and going to 8x or 4x. This is actually the same thing as reducing the pixel size. Okay, so if I so let's do that and let's go render here. Do you see how pixelated it is at 4x? How pixelated it is at 8x? Okay, let's go back to automatic now. Stop the render here, go back to rendering here in the small screen and really zoom into it. What you are going to notice is that it's actually the same thing. It's about reducing the pixel size. Okay, so what we did here was reducing the pixel size actually. Um, kind of without reducing the pixel size in the Blender performance settings, but kind of doing it physically, you know what I mean? Uh, so that's one way to take a quick peek in your renders um, by gaining a huge performance boost. Okay, that's how we do it. And then when you do your final renders, you can go crazy and render in 4K if you want. You may have to wait for 2 months for your 1 hour animation, or not, not 1 hour actually, like maybe 10 minutes of your animation to finish. You may have to wait for 2 months, but you are going to get a very high quality render at the end. But while you work with Blender, you want to work as fast as possible and you want to get as much performance as possible out of your computer. So that's one of the tricks that you can do. I'm going to open another project of mine to see if we are rendering fast still. The lab, yes, here we go. This is an old project of mine where I modeled the computer lab from my university. Um, it was a very beautiful room. I really liked it. It had these brick walls, these concrete, naked concrete walls. I really like the architecture here. So I went ahead and modeled it in Blender. It was very cool. We are rendering in Eevee right now. I'm going to go back to viewport shading. And here on the top right, I'm going to switch the window to 3D viewport. And I'm going to render in cycles, okay, not in Eevee. I'm rendering in cycles right now. And even with the worst CPU that you can find, even with the worst CPU that you can find in Blender benchmark, I'm actually rendering kind of fast, okay? This is nothing to sneeze at. I'm going to zoom in now to take a better look at my render. Great, I like it. I go back and I do certain edits. I do, I keep using Blender. So I will choose the sunlight over here, for example. I want to change the direction of the sunlight. I want to move it a little up like that. I want to zoom in. Wow, I like it. Beautiful, whatever. And that's how you use Blender fast. I hope you learned something in this video, and I will see you in the next time.
Yeah. The youths in the streets, they can't find no food to eat, and they don't have nowhere to sleep. We're gonna protect them. We're gonna guide them. We're gonna save them.